Good morning, good afternoon, or good evening, everyone. It is a pleasure to be here today to moderate the final session of the GOOS BioEco EOV webinar series hosted by the Marine Biodiversity Networking Fridays and jointly organized by the Global Ocean Observing System, the BioEco Ocean Project, the Marine Biodiversity Observation Network, and the Air Center. My name is Véronique Elfer. I am a mangrove ecologist working at the Leibniz Center for Tropical Marine Research, ZMT, in Germany, within the research program area Ecosystem Co-Design. My research focuses on understanding how taxonomic and functional diversity, considering the flora, fauna, and macrobiota, supports ecosystem processes and services in order to provide knowledge-based recommendations for the protection, re-establishment, and sustainable use of mangrove ecosystem, for climate change mitigation and adaptation, and more generally for coastal resilience. In this context, the mangrove cover and composition EOV is certainly of paramount importance. I am therefore honored to moderate this session today with a wonderful panel composed of two mangrove ecosystem experts, Daniel Fries and Firni Budi-Arifanti, and two coral systems experts, Nasira Bax and Erika Tall, who will share their insights on the mangrove cover and composition and the coral cover and composition EOV, respectively, and the opportunities and challenges related to them. Let me now briefly introduce our panelists, starting with our mangrove experts, Daniel Fries and Firni Budi-Arifanti. Daniel Fries is the Cochrane Family Professor of Earth and Environmental Science at Tulane University and the director of the Murphy Institute's Center for Public Policy Research. His research interests focus on the benefits that mangroves provide, particularly related to blue carbon, the human and climate change impact on mangrove ecosystem, and how we can use blue carbon to incentivize mangrove conservation and restoration. He conducts his research predominantly in Southeast Asia. Due to his expertise, Dan is a member of the IUCN Mangrove Specialist Group and the International Blue Carbon Initiative Scientific Working Group. Firni Budi-Arifanti is a principal researcher at the Research Center for Ecology, National Research and Innovation Agency, BRIN, in Indonesia. Her research focuses on mangrove ecosystem, wetland ecology, greenhouse gas inventories, and blue carbon, with a particular interest in carbon dynamics and nature-based solutions. Since 2022, she has been engaged with the Ramsar Convention on Wetlands, serving as Indonesia's focal point to the Scientific and Technical Review Panel, and as a technical expert for the 2023-2025 triennium, and more recently as scientific expert for the 2025-2028 triennium. In 2025, she became the chair of the Indonesian National Committee for the Man and the Biosphere UNESCO program. Insights into the coral cover and composition EOV will be provided by Erika Tall and Narisa Bax. Erika Tall from the National Oceanic and Atmospheric Administration Office for Coastal Management is a marine biologist currently serving as the coordinator for NOAA's National Coral Reef Monitoring Program, a long-term national-scale program aiming at understanding the status and trends of coral system in the US states and territories. She is in charge of facilitating the exchange and collaboration between various actors, federal agencies, NGOs, and academia, and provides technical scientific expertise on all coral monitoring program decisions. She's also responsible of maintaining the data stewardship, quality assurance and control, reporting, and archival. Erika is the recipient of the prestigious NOAA Knaus Fellowship and served as a fellow in the US Senate's Commerce, Science, and Transportation Committee within the Subcommittee for Oceans, Atmosphere, Fisheries, and Coast Guards. Last but not least, Narisa Bax from the Pingortitalerific Greenland Institute of Natural Resources at the Greenland Climate Research is a New Zealand Aotearoa-born marine ecologist and deep-sea coral specialist with a research focus on polar and subpolar seabeds, looking at how these biodiverse environments contribute to carbon cycle in the context of climate change. She provides technical scientific expertise to the GOOS Biology and Ecosystem Panel and co-leads the Coral EOV. Specialized in the coral family Stylasteridae, she contributed to the first IUCN Red List of threatened species for cold water corals and the third cold water coral and sponge subchapter of the next UN World Ocean Assessment. She was awarded the Deep Ocean Observing Strategy Future Leader in Deep Sea Science honorarium in 2022 and was chosen as ambassador in 2025. With this wonderful panel, we will certainly have a rich and dense session, so let's dig or dive directly into it. Dan and Firni, the floor is yours.
Thank you so much for your kind introduction. Let's just share my screen. Please let me know if you can't see the slides. Okay. Thank you so much. And it's a great honor to be here, great honor to present with Virni, and also to acknowledge Steve Canty, who's a real key driver of this process as well. Before we get into mangroves, I thought I'd give it just a quick introduction to what the Global Ocean Observing System is and some of the things that we're going to be talking about. The GOOS is led by a number of organizations, the Intergovernmental Oceanographic Commission of UNESCO, co-sponsored by the World Meteorological Organization, United Nations Environment Programme, and the International Science Council. And since 1991, it's been serving as this critical system for monitoring the state of our oceans. It provides data and essential information needed for sustainable development, safety, well-being, and prosperity. And so it leads us and supports a community of international, regional, and national ocean observing programs, governments, agencies, research organizations, and others. And it's been particularly playing a key role in climate monitoring, as well as operational services, ocean health assessments. The list goes on. And to maintain and enhance this system, ongoing support is provided from various stakeholders, including national focal points. So, and of course, there are many reasons why we need to observe the ocean. Obviously, our oceans are changing. They experience a range of stresses. They're used by a number of different stakeholders and are an integral part of the economy, and particularly the blue economy. But the ocean is so big, and the things we need to measure are so numerous that there's no one country or organization that can observe it on its own. So we need this collaborative approach. And it takes this collective effort, right? It needs coordination so that we go beyond this fragmented approach to collecting observations. Particularly when it comes to biology and ecosystems, what we measure and how we measure it can be interpreted very differently. And we follow diverse standards for data. And we often have poor access to the data that we need. And this has led to real difficulties in harmonizing and comparing data across regions to assess the health of the ocean. And we also see around the world an unequal access to monitoring capacity and capability information. Now, as part of this, we use the essential ocean variables, and this is really the minimum set of variables that we need to assess across different ocean states and ecosystems. And you see in this figure, it's really a hierarchical aspect, and they're grouped by disciplines. And we have expert panels overseeing different aspects of this. And then the EOVs, are described by these key elements of subvariables, supporting variables, and derived products. And zooming into the biology and ecosystems EOVs, this just gives you a range of the ecosystems and ocean biodiversity that are captured under EOVs. And through this, it provides this framework for coordinating ocean observations across these different systems to ensure globally comparable and combinable data. And so the GOOS, along with MBON, are two coordination programs working with these essential variable frameworks, and they are connecting the various communities that are using these information. And you see in this loop really the key global data and information systems that are really central to this effort, so that we can make information discoverable and also integrated across these different platforms. Okay, and so we're going to be talking about a couple of these specification sheets for mangroves and corals today. So let's dive into mangroves, and I'm going to give a quick introduction to maybe the state of the world's mangroves and why monitoring is so important. And then Vinny is going to get into the nuts and bolts of what that EOV looks like. So I think mangroves are a fantastic candidate for this system because uh, they are experiencing a huge amount of stress around the world, and we used to consider mangroves as one of the world's most threatened ecosystems, being lost at 1 to 3% per year, which was as fast or greater than many other systems on the planet. Um, to the extent that, scientists, only a couple of decades ago were thinking what a world without mangroves would look like. That was kind of, the fear at that time. This was important because it did start to get mangroves on the international conservation agenda. And what was causing all of that loss? There's a number of different issues and stresses that affect mangroves, and they differ depending on where you are around the world. So if you are in Southeast Asia or places like Ecuador and some parts of Latin America, mangroves are facing a threat from aquaculture, so for food production and protein production, and that has really driven a huge amount of loss, particularly across Southeast Asia. In some parts of Southeast Asia, we have conversion of mangroves to rice paddies. We have increasingly conversion of mangroves to oil palm plantations. So, all of these are commodity driven production. In other parts of the world, it's more local use of mangroves, which are causing degradation if not managed, and for example, overharvesting in some parts of the world. And in places like West Africa, we have big issues with pollution, particularly oil pollution. But there are a number of natural stresses as well, and particularly cyclone impacts in the Caribbean, in the Bay of Bengal, and other parts of the world, which can really have an impact on mangrove structure. We have shoreline erosion, particularly in parts of South America and again the Bay of Bengal, India and Bangladesh. And increasingly, we're seeing impacts of drought. So, for example, in 2016, during an El Nino year, mangroves across a 1,000-kilometer stretch of the North Australian coastline suffered a very rapid dieback due to drought and a drop in sea level. So it's hard to manage these threats because some of them are human, some of them are natural, some of them are exacerbated by human management actions. And then, of course, on top of that, let's talk about climate change and sea level rise and increased cyclone activity and all these things. And so mangroves are facing this multitude of interacting stresses. But good news is that we think that the rate of mangrove loss is actually reducing to what we thought it was of 1 to 3% per year. These are just various estimates, and the estimates differ. But what's interesting is that around 2000, it looks like we might have a reduction in mangrove loss from 1% or 0.7% per year to anywhere between 0.1 to 0.4% per year. And so we're starting to bend the curve, at least on the amount of global mangrove area that's being lost. And there's a number of different reasons for this. Partly it's that we're better at monitoring. And so I think our numbers are maybe a little bit more robust after 2000 than compared to before. But I think it really is a true conservation success as well. And partly that's an acknowledgement of the importance of mangroves across various stakeholders and national governments. And blue carbon has played a big role in that, but so has coastal protection and other benefits. But it's also, we're starting to see a lot of ambition in restoration and trying to bring back mangroves that were lost. And countries around the world have set, really ambitious targets of hundreds of thousands of hectares of restoration in the coming years. So, this is all good news so far. And a recent study that came out just a month ago or so is showing that actually mangroves may be expanding in many parts of the world. So this is looking from kind of the 1990s onwards, and again with better data and tools that we're able to see that it's not as doom and gloom as maybe we thought it was 20 years ago. And many regions are actually showing a net increase in mangroves, particularly around kind of 2010. But as this graph shows, it's not, there's still a nuanced story behind that. And, we are having new growth and expansion of mangroves, but we're still having habitat loss. And so it's not that we've completely solved the problem. And yeah, we are having this expansion, but it's still being offset by habitat loss. So there's still work to do. Mangroves also don't just face deforestation and area loss, but they also face degradation. And this graph shows that maybe degradation is reducing as well, and that we're getting a thickening of mangrove forests, and this closed mangrove forest category is also increasing, which is good news. But of course, degradation is also really difficult. There's many different ways of defining and indicating degradation. And obviously, the studies I've shown you are all remote sensing, and that is great, but it only gives you a snapshot of one aspect of the ecosystem. And so this is why I think the EOVs are really important, because this gives us a much more comprehensive and repeatable set of indicators where we can get a real true idea of mangrove condition. Over to you, Vinny.
Thanks, Dan. So now I will be talking about mangrove cover and composition specification sheet. Next slide, please. So the mangrove cover and composition specification sheet is intended to provide detailed information about the variable of the mangrove ecosystem and how to measure and manage the mangrove EOV data. So in this specification sheet, we have several variables to be measured. First are the sub-variables, which are the key parameters or the measurements that are used to estimate the mangrove EOV. So under the sub-variables, we have the mangrove areal extent or canopy cover, and then we have the species composition and zonation, tree height, and diameter. So these are the three major sub-variables that are needed to be measured for estimating the mangrove cover and compositions. And then we have the supporting variables. These are the measurements that are useful to provide context to the sub-variables of the EOV. So we have biological, environmental, and EOV-related supporting variables to give context to the sub-variables of the EOV. And then we have derived products, which are outputs that can be calculated from the EOV and the sub-variables. So, for example, from these EOV sub-variables and the supporting variables, we can generate mangrove distribution estimates by calculating areal extent and fragmentation. And we can also generate species composition and dominance, mangrove biomass, and carbon storage. Next slide. Next slide, please. And then on the next section of the specification sheet, we have the phenomena to observe. So phenomena are the processes that can be characterized by the EOV. So from the mangrove cover and compositions, we can help to understand the habitat status and trends. And then we can also observe the changes in species composition and the carbon storage. And for each phenomena, the spatial and the temporal extent is described, and also the resolution needed to be captured. Next slide. Next slide. And then on the next section, we have the observing specification or requirements, which are the ideal measurements for an optimal observing system for the EOV. So, for example, if we would like to measure the areal extent or canopy cover, we can suggest you several resolutions that can be used, for example, from the minimum, desirable, and the ideal. So the minimum resolution that can be used is we suggest for 30 meters. But if you have higher resolution, such as less than 5 meters, that is most better. And then we have also uncertainty measurements, sampling approach, and the references that can be referred to. Next slide. So the same goes for another subvariable, that is the mangrove species composition and zonation. So we have provided the resolution, the uncertainty, the sampling approaches, and the references to be referred to. Next slide. And then for the last subvariable is the tree height and diameter. Here you can also find what kind of resolution and the sampling approach that can be used to estimate the tree height and diameter if you would like to observe, for example, carbon storage in a mangrove ecosystem. Next slide. And then in the fourth section of the specification sheet, you will find the observing approach, platforms, and technologies that are used to collect the EOV. So for the observation of mangrove cover and compositions, we have 3 approaches. First is the in situ measurement of the mangrove. So if you would like to measure the mangroves on site, we can use several techniques and sensor in the field. And here we also provide the methods and best practices to be used. And then the second approach is the remote sensing, where you can use satellite-based optical or radar, or using drone or LiDAR to estimate the mangrove cover and composition. And then the third approach is the modeling approach, where you can use GIS or modeling softwares. And then here you can also find the methods and best practices that can be used for each approaches. Next slide. So the idea of this GOOS initiative is actually how we can compare the data across regions, how we can share our data and make it public. So if you have your data and you would like your data to be accessible for public, you can upload your data on OBIS, and you can also go to the GOOS BioEco portal, which is an interactive map, which is showing who is collecting the BioEco EOV data, where the data has been collected, and you can also find other metadata in this BioEco portal. Next slide, please. So this whole initiative is actually a collective and a collaborative work from many organizations, and we would like to thank all these organizations for supporting the GOOS BioEco panel on developing the BioEco specification sheets. Next slide, please. So at last, I would like to end our presentation on Mangrove EOV, and thank you for your attention. I would like to give over to Veronique.
Many thanks, Virnie and Dan, for this very nice presentation regarding mangrove ecosystem. We will now transition to the coral systems with Erika Tall starting, right?
Thanks, Veronique. How does that look? Does it look okay? Full screen presentation mode? Excellent. Thank you so much. It's an honor to be here. Thank you, Veronique, for the introductions. Thank you, Daniel, for sort of setting the stage for what EOVs are and why they're important. Narissa and I, as co-leads, want to specifically thank Ariane Buckenmeyer. She was hugely essential in helping us co-create the specification sheet for hard coral cover that we're going to talk about today. So a huge thank you to her for her support and collaboration. Okay, let me make sure I can advance this. I'm just double checking the slides advanced, right? You're seeing the slide that says outline? Hopefully. Okay, great. So today we're going to switch to the coral EOV now, which I think is a nice segue because obviously in many parts of the world, shallow coral reef, tropical coral reef ecosystems are very connected to mangroves. So having both EOVs in this seminar is certainly relevant. And we'll talk about some of the challenges that are unique to this EOV and some of the opportunities for better integration across long-term monitoring. But I think one of the things we really want to highlight is the update to the specification sheet specific to this coral EOV is very unique and different from the previous specification sheet because it incorporates deep and cold water corals. So previously we had only focused on tropical shallow corals. And so Narissa, who's an expert on these ecosystems, is going to talk after me about this, but that's like one of the biggest changes, which was a big challenge for us in updating this specification sheet to include deep and cold water corals as well. So that's a big and new and exciting change. We'll talk more about that shortly. So thanks for being here, and thanks again for the opportunity to have us here. So our specification sheet really focuses on 4 major subvariables. So coral condition and health. And again, let me just reiterate, we're really talking mostly about hard corals or sclerotinia here. Coral diversity, live and dead coral cover and aerial extent of those benthic habitats. Density and abundance, but also the total habitable substrate when we're thinking about recovery and regeneration, thinking about the available benthos for corals to potentially regenerate and repopulate is something that's become really important to us in terms of measuring this EOV. And as you can imagine, there's lots of supporting variables that support this and are critical to really understanding some of the phenomena that we'll discuss. Those include temperature, pH. I won't read them all, but because corals are so threatened by global climate change, these supporting variables have become as just as critical as they ever have been. And Vernie did a great job of explaining what the phenomena are, these desired observations that we're trying to capture here with the collection of these EOVs. For coral reefs, we're really looking at status and trends. Like, what can we say about these ecosystems? Are they, how are they declining if they are declining? And really focusing on extreme events and mass mortality. So for shallow coral reef ecosystems, which is my personal focus area, that's really thinking about coral bleaching and thermal heat stress events, and of course, potential recovery and resilience. Trying to sort of track and measure that following these mass mortality events. So that's really been the focus of our updating of the specification sheet. So the derived products that we're really talking about here are very diverse. And so, when we talk about coral cover and aerial extent, we're really thinking about products like GIS map layers. When we're talking about coral health, we're really thinking about, can we create inventories of potential disease or potential bleaching prevalence? And one of the challenges, I think, of this EOV is coral diversity, particularly between ocean basins. In the shallow water context, as many of you might know, there are very different species between the Atlantic Ocean basins and the Pacific Ocean basins, and there are actually many more hard coral species in the Pacific basin than in the Atlantic. So when we're talking about potentially getting data to be more standardized across the globe, it's really hard, even at the species level, let alone the genus level. So that's certainly been a challenge historically. And so, one of the things why it's so important, and I think most people on this call are aware of this, but coral reefs are really considered to be the rainforests of the sea. So, the sort of the terrestrial ecosystem equivalent of this very biodiverse place like a rainforest, right? And so, really trying to understand how these ecosystems may or may not be changing, especially in the face of both local and global threats, is more important than ever before. So the challenges that we've been facing are, we're hopefully we can see them as opportunities as well, but they're definitely not trivial. And they're different across the shallow water coral space, which we're loosely defining as reefs from 0 to 30 meters. So pretty shallow, like 100 feet or 30 meters or less, right? So They have varied habitats in terms of the rugosity of the benthos. You might have a patch reef, or you might have a low relief or a very high relief, highly rugose benthos. And so, making sure that your methods are standardized across those different habitat types is very important. As I briefly mentioned earlier, the multiple taxa and the difficulty in getting to very specific taxonomic levels has been a challenge across this EOV. Different data methods. One of the things that I think is really interesting, in the figure on the upper right hand corner, we sort of look at different methodologies and how they span different temporal and spatial scales. So you can imagine that when you're working across multiple, partners globally, and all these different potential tools in the toolbox to collect the EOV across these very varied temporal and spatial scales, it becomes quite difficult to standardize and rectify that. And just to give you an example, and you can see some examples at the bottom there, in a shallow coral reef context, we're really thinking about or historically classic methodology has been visual census. So literally putting a diver in the water and having that person collect the information in situ. But of course, there's a lot of limitations there, especially in super remote places in the world. And so, more and more, I think we're thinking about filling gaps using remote sensing, whether that be satellite-derived imagery or aerial imagery from drones, for example, as you can see in some of these images. And then, of course, as Narissa will talk about shortly, in the deep ecosystems, obviously those things aren't available. Satellite's not going to penetrate to those depths. Scuba divers can't go to those depths. And so now we're talking about sleds and trawls and cores and ROVs and AUVs. So just this huge diversity of methodology that has made it, really exciting, but also really challenging to integrate from shallow to deep. So there's still a lot to discover. And of course, we're not going to talk too much more about eDNA, but we thought it was important to mention it. It's being used more and more in many EOV fields, and certainly corals is not an exception. We didn't feel like we were ready to sort of try to standardize that within the spec sheet because the field is ever evolving. And so to try, that really hasn't fully transitioned from research to operations yet at this point. So I think one of the things that's most exciting about the work that we're doing is the why. Like, why do we care about updating the specification sheet and getting better standardization globally? I have the honor of sitting on the Global Coral Reef Monitoring Network, or GCRMN, editorial team for the Global Status Report. And one of the things previously, a few years ago, we undertook the opportunity to make a status report, the first based on quantitative analyses of a synthetic data set. I think we had more than 300 scientists contribute data from over 72 countries, I believe. And of all of those subvariables that I had mentioned, the only ones that we were able to use in the report were percent hard coral cover and percent macroalgae cover. Those are the only two variables because it was just impossible to standardize across everyone's different formatting and different collection methods. And so I think that was a huge wake-up call for us of like, that's all we can say, just the bare minimum sort of like lowest hanging fruit, if you will, of percent cover. So we're in the process of undertaking a data task force to make sure that we're really integrating these data sets in a way that allows us to say something more specific, and also making sure that we're recommending interplatform standards such as Darwin Core, so that we're not taking so much time to sort of translate and rejigger everybody's formatting when we collect all this data together. So for me, it's been a huge honor because there's been such a nice synergy between what the GOOS specification sheet process has been and how it directly feeds into and improves these processes, like actually in real time trying to make a global status report. So more to come on that. But it's really been, I want to reiterate, it's been an honor to be part of this process. So thank you so much. I'm going to transition over to Narissa so she can talk a little bit about her experience within the deep and cold water ecosystem space. Narissa, over to you, but I'm happy to advance the slides.
Thank you so much, Erica. That was brilliant. I am going to go straight into some of the particular challenges of incorporating cold water corals into this EOV. And similarly to Erica, using a real world example of looking at, trying to understand on a global scale how these ecosystems are changing. So the case study for this is the UN World Ocean Assessment. We're up to the third World Ocean Assessment coming out next year, which I am kindly a part of that chapter. Eric Cordes has led all three of them. And some of the key kind of overviews that we are seeing is that cold water coral gardens and reefs are nearly ubiquitous on hard substrata across the world. So when you think about what Erica presented in terms of the kind of tropical band for warm water corals, this means that we are now extending across all latitudes and then also significant depths down to thousands of meters. And even in these environments, we are seeing quite profound physical and chemical changes in the deep oceans, which threaten these habitats. And we have the human element, which also Daniel very well touched on for, globally, we have the human development problem along with climate change. And so some of these specific aspects in the deep sea are things like deep sea mining and marine carbon dioxide removal projects. And it's also very much an area of discovery, which we are continually discovering new aspects in the deep sea. And we're also shifting, like many areas of research, to not only discovery, but looking at regeneration and opportunities for restoration. And there's the bigger story of how to manage these ecosystems, so ecosystem-based management on large scales as well. Next slide, please, Erica. And so I wanted to use these images to illustrate some aspects of this. So on the left, we have the image from the World Ocean Assessment. And so this largely shows that cold water corals are associated with your hard substrates, so locations like seamounts and shelf and slope habitats. And it's also based on habitat suitability modeling, which is a large part of what we use to understand the deep sea, because only the latest numbers are that 27% of the seafloor is mapped. So that's in large part thanks to projects such as the UN Seabed 2030 program. And so their original goal was to map 100% of the ocean by 2030, and we're up to 27%, which I think sort of illustrates that even if we know where the habitats and structures are, to actually ground truth and understand what is there is a very difficult task to move towards as well. And so I included on the right an image from a project led by my collaborator here at the Institute to go to East Greenland next year, and we will be looking at deep seamount chain and hydrothermal vent communities. And it's also important to understand that, you've got beyond we understand that the habitat is there, particularly for the deep sea. This is largely based on imagery and video data, if you have specimen data at all. And so really understanding and ground truthing is particularly hard. And it's also in the context of monitoring particularly hard when this is where we're starting. So thinking about the temporal scale that you would have for other shallower ecosystems, we are starting now in many of these habitats. And the expense and logistics really limits how often you can go and monitor from here as well. Next slide, please. And one of the, I think particularly this is also a problem in the shallow coral community, thinking about the broader picture of understanding the biodiversity and the taxonomy, as particularly in the case of deep sea corals, where you have these kind of habitat forming species. And so I just wanted to go through and introduce you to some of the characters in the deep sea. This is the Stylasteridae corals that I work on, and this image is from Antarctica, for example. And Erica, next slide. And then you also have these beautiful soft corals, more commonly called things like cauliflower corals. And this is an example of a vulnerable marine ecosystem here in Greenland. Next slide, please. And then you have the antipatharians, which are the black corals, and this is an image from the fjords in New Zealand. Next slide, please. And then we have the scaloractinian corals. And the Lophelia petusa, Desmophyllum petusum example is particularly relevant because this is habitat-forming coral species, largely in the Northern Hemisphere. And now that we have the molecular tools to investigate taxonomy in a different way, this is a species that was originally known as Lophelia petusa and is now categorized as Desmophyllum petusum. So I think it kind of illustrates one of those key aspects in not only having your quantifiable understanding of the biodiversity, but maintaining and updating that and having that applicable on a large, broad scale for ecosystems as well. It's particularly important for the coral EOV, which is considered habitat, but also essential climate variable as well. Next slide, please, Erica. And another thing that we've been talking about a lot, and this came up in, we had some workshops on with the experts around the world on what to put into the coral EOV. And it's not only your live coral cover, but also your dead framework forming and even the fossilized aspect of that. So it's not just what you see that is living, but how that is changing and how the dead framework coral also is a very important part of the ecosystem and part of the broader ecosystem services that these habitats provide as well. Next slide, please, Erica. And so we wanted to just give you a brief overview of what we're thinking in terms of the future of the coral EOV. So we have had some workshops with the community recently, and what we really want to do is utilize this information so that we can bring together an understanding of what the trends are and how these ecosystems will respond to climate change. Also understand if there is already some aspect of consensus on the observed impacts of climate change and coral cover and composition. And if it's possible to get this information based on the integration of the current infrastructure that we have as well, and see where we can utilize that, and also recognizing within the bigger picture that monitoring is largely, particularly for the deep sea, centered around developed countries. So you will have much more information for North America, Europe, Australia, whereas there'll be large gaps in Africa and Asia and South America. And then even when you have some nuance in the understanding of those areas, it might be focused on areas which are overseas territories. And then also beyond that, thinking about how much of this data is within the framework of FAIR, and also particularly important for somewhere like Greenland, within the framework of CARE, so based around Indigenous data governance as well. And some of the recommendations that I think the broader community that we're talking about a lot within GOOS as well is that we want to create a specification sheet that's not only a product, but something that really encourages data collection rather than makes it harder than it already is. And then also within best practices and also integration within the other EOVs. So one of the key ones for the coral community might be sponges, for example, because they're also similar within the ecosystem engineer context. And also across the panels, it would be good to get more integration as well. And we welcome any feedback from the community. And thank you so much for your time.
Thank you very much, Erica and Narissa, for your contribution regarding the corals. I really appreciated the emphasis you put on standardization of approaches, Erica, and you, Narissa. Thank you very much for making us dive into the deep sea. I never saw such nice pictures, and also for reminding us that data sharing should be fair. So we have several questions in the chat. I would like to start with a question for Dan by Chandra Karash Sarma. So Dan, you highlighted it's not all doom and gloom for mangrove, but how do we ensure that the message of conservation and restoration importance is not diluted when we have such positive trend? And are those positive trends supported by standardized global surveys, or are they based on local observation and local measurement methods?
Thanks. This is a great question. First of all, I think it is important that we celebrate positive trends. There's a lot of people around the world and a lot of governments investing a lot of effort and time and money into conservation, and I think we need to acknowledge and that and support it. So we encourage people to do it even more, right? But of course, the job is not done. So just because we have overall net growth doesn't mean that we're not still losing mangroves, and it's that portion that we still really need to focus on. So we can't hang up our muddy field boots just yet, right? There's still work to be done. The graphs I showed you in some respects are standardized because it was a global remote sensing study, so it was all using a single method. But of course, it's just one indicator of overall condition of mangroves. And that, getting a more holistic view of mangrove condition is where we're really struggling because we do have different networks and different approaches. For some things, we do have standardized global manuals and things like that, but people have to know about them in order to use them, right? So there's definitely a need for more coordination, and different national governments will use different methods and all these kind of things. And this is really where the EOV, I think, plays an essential role because it's from the community what we think these key standardized indicators should be. So there's still a lot of work that needs to be done in that space. Thanks.
Now I would like to turn to Firni. There is a question by Sidi Shoshi. When mapping mangrove carbon stocks, what are the best standardized parameters to include in the assessment? So we have seen with your presentation that for the EOV, you are considering the stem diameter and the tree height. Any other parameters that would be important?
Yeah, I think the canopy cover, the canopy density is also important. And so above ground biomass, I think that's the most straightforward parameters that can be measured from the satellites. But for sediment organic carbon, I think you cannot observe the sediment organic carbon from satellite imagery. So you have to take the samples in the field and you have to analyze it in the laboratory. So I think if you would like to map the mangrove carbon stocks, which is the most straightforward thing, is by mapping the above ground biomass by using the tree height, diameter, canopy cover, and probably species composition. I think that's it for me, Veronique.
Thank you, Firni. If I may also jump in with some questions, I would like to ask Firni, you mentioned the temporal resolution that you would advise us to use, but I assume that the EOV would also welcome snapshot studies, right? So if we conduct a study, yeah.
Yeah, sure. So the numbers that are provided in the spec sheets are not mandatory. So it is all that. So these numbers are suggestive numbers. So if you have higher resolutions, we would like to have it. I mean, it's much better. But so you don't have to stick on the numbers that we have provided on the specification sheets, and we are open to any feedback for the improvement of the specification sheet.
Thank you, Firni. Now we will go to the coral systems. Again, a question for from Chandrasekhara Sarma. In some regions, synthetic or man-made coral reef are being developed as restoration intervention. How are these structures assessed for their ecological impacts on existing natural reef ecosystem in terms of species composition, biodiversity, and long-term resilience? And within the EOV framework, is ocean acidification being monitored as part of the chemical environment alongside coral cover and composition? Erika or Narissa?
Sure, I'm happy to start, and then Narissa, if you want to add to it, please feel free. The restoration question is a really critical one, so thank you for that. It's a great question. On a global scale than the specification sheet, we have not come to consensus on that yet, but I can speak from the program that I run, which is in the US. We have started within our monitoring program to note if certain key restoration species in the Atlantic and Caribbean, that I'm specifically speaking about Acropora cervicornis, that I think remains one of the most, the fastest growing and most highly outplanted, at least in Florida and the Caribbean at this stage. We have started to make sure that we're noting if those species are seen, if they have tags on them, that would indicate that they have been restored, right? As opposed to a natural colony, like a wild colony. And so the idea with that, I think, is getting at your question of like, can we start to see the effects of restoration? Like, can we actually tease out, are we seeing increases in the population of that species, for example, because we're noting if they were restored corals? And so I think we're not fully ready, although probably getting closer and closer, but not fully ready to integrate that piece into the global specification sheet, just because I think the understanding of where restoration sites are is not something that's necessarily like totally public information, like within marine protected areas and special protected areas. So it sort of brings in this additional new challenge within all the challenges that we talked about. But the phenomena that we do want to focus on, I think I mentioned this, is recovery. And so I think restoration is a part of that. So it's definitely something we're thinking about, though not fully fleshed out. And would love feedback on any of that. But yes, I think it's something we're very actively thinking about how to incorporate, and certainly welcome any recommendations. From the OA perspective, yes, absolutely. Within the supporting variables, we have pH, we have oxygen, we have total alkalinity, we have dissolved inorganic carbon, DIC, So like all of those things that you would need to look at carbonate chemistry to assess sort of OA impacts on corals is very much a consideration within the supporting variable framework. So great question, and thank you for that. Narissa, did you want to add anything from your perspective?
I think you did a brilliant job. And I think particularly with the restoration, it's much more applicable in shallow waters, but there are kind of pilot projects looking into that for the deep sea, which I haven't specifically been a part of. So my focus has largely been polar areas of, places that have very little knowledge generally. But in terms of ocean acidification, that is one of the primary threats in these ecosystems as well. So just putting that forward as something that would be applicable across both groups.
Thank you. Now we have a question from Mayur Fulmali, again to Dan and Firni. What research are you expecting from young researchers to take up so to contribute to the GOOS EOV? Maybe this can also apply to Erika and Narissa. Please feel free to contribute.
Vinny, go ahead, since you're leading the EOV. Yeah.
Oh, yeah, I think there are many research that can be contributing to the GOOS EOV. So I think now the trending topic is on carbon measurements in mangrove ecosystems. So if you would like, for young researchers, if you would like to do research on mangrove carbon or mangrove carbon dynamics, and also mangrove cover composition, for example, because we also need to distinguish several mangrove species, and therefore we need very high resolutions. But if you don't have this high resolution imageries, you can also use satellite imageries that are free to be used. So yeah, would encourage all the young researchers to check our spec sheets, because there we have the minimum requirements for the data collections on mangrove ecosystem. Yeah. And then if you can add, please.
Well, just to say that, the EOVs also are a community of researchers, right? So it also, I think, as an early career researcher, it also gives that there's ways to collaborate and give access, and coordinate with other researchers from around the world. And I think that's what's really exciting about mangroves, is that we're a very international research community. So I think that's a really cool part of this, which you might not get with working on your own with your own methods. Yeah.
Talking about international collaboration, then Bolarinwa Balogun, excuse me for the pronunciation. She asked the team on mangrove whether there is a monitoring network in Africa that is working on the ground to generate in situ data to contribute to this global database. as we all know that remote sensing is a good tool, but cannot give all important information.
I don't know.
Okay.
How about you then?
Sure.
I know
I mean,
that.
yeah. Okay. Yeah, I don't know of any, monitoring networks specifically for, for the EOV, right? But there are awesome mangrove researchers across Africa. And so there are a number of networks there. There's the African Mangrove Network, which I think is more a kind of an NGO nonprofit network. There's the in East Africa, there's the West Indian Ocean Mangrove Network, which is a really vibrant and great group. There's Digital Earth Africa, which might have some things, and I think the one in West Africa, there's maybe not so many internationally prominent networks, but there's great researchers there too, and there is a West Africa mangrove group out of the Dhaka Ecological Monitoring Center that I'm aware of. So there are people there doing great stuff. And yeah, I guess it'd be great if we can, coordinate some of these things, but there's definitely on the ground data collection happening and a really vibrant community. And feel free to email me. I'm happy to put you in touch with some of those folks that I mentioned.
Excellent, Dan. Thank you very much. As there are no more questions in the chat, I will again ask Firni and Dan about a question about mangrove ecosystem. So there are now more evidence that shows that it's functional diversity or functional distinctiveness that is driving important ecosystem processes in mangrove. And at the moment, from what I've seen, functional traits are not integrated in the characteristic that you are recording within the EOVs. Do you think this is something that we could think of for the future to also integrate functional traits of mangrove plants within the EOV?
Yes, certainly. Yes. So so this is only because this spec sheet is only on mangrove cover and composition. So we can make another specification sheet more detailed on the mangrove functional traits, for example. So this is just the first stage, Veronique, on the mangrove specification sheet. So if we finalize the specification sheet, then we can make a new specification sheet on mangrove functional traits, for example. So we are open to any feedback.
Okay, I will get back to you. Another question now in the chat from Frank Müller-Kage. Do you see it as important that people that are already collecting these observations, doing monitoring, plan to do them or support them, use the language of EOVs? Can you explain why and how do we get there? So I guess Frank is referring to some ontologies to ensure standardization across observation, right? Who wants to take it? Erika?
I'm happy to start. Yeah, hi Frank, thanks for that question. Yes, I think it is really important that we're all speaking sort of the language of EOVs. And I think that the example that Narissa that gave us at the end of her talk about like dead coral, live coral, total habitable substrate, like we all need to, like people don't necessarily all agree on what those things are. They're not. So I think in order to be standardized, we have to be speaking the same language, right? Like somebody could say like, what do you mean by old coral mortality? What do you mean by lives? You know what I mean? I just think there's so many, in order to actually functionally be standardized, we do need to be using this language. And I don't think we need to reinvent the wheel here. So I think the short answer to your question is yes. How do we get there? Ooh, I don't know. I think we need like, I'm sort of saying this like tongue in cheek, but we need like almost like a marketing campaign. Like I think we as scientists aren't always the strongest at like communicating these things, right? We're not, some of us, that is a strength that we have, right? But not all of us, right? And so I think in order to really get full buy-in, we have to really put effort into like going on sort of a tour, if you will, in the spaces that we're in and educating people about the EOVs and this language. doing webinars like this is a great way to reach people, but obviously we need to reach more people. So certainly welcome any ideas about that. But yeah, I mean, I think a lot of us like have our day jobs, right, that we're focused on, whether it's monitoring and actually doing the science. And so I think that sort of the outreach about a lot of this has to take a back seat because we all have our regular jobs. But I think we do need a focused effort on communicating if we're actually going to implement this a little bit on a larger scale. Narissa, did you want to add to that? I know we're at time, so I'm sure we want to start to wrap up, but just want to give Narissa the chance to respond too.
Oh, I think that's brilliant. And it's a very hard compromise because there's also the inverse of that, where we are going to the communities of practice and trying to figure out how that language is used and can be incorporated as well. And beyond that, because we're also trying to go global, there's a space to consider whether we should be thinking about translating these into other languages to increase the uptake and that sort of thing as well. So language is a very big issue that we should definitely be considering more broadly.
I think this is a very important statement, and we can keep it as our final statement for today. I would like to thank again our four panelists for this very vibrant webinar, and also all the audience for the very interesting questions. So I wish you all a wonderful time over the holidays, and I know it's early, but let's start already a nice start into 2026. All the best, and thanks to everybody.
Thank you.
Thanks, everyone.
Thank you, everybody.
Thank you.